Okay, so for today's lesson, I'd like you to have a go at the exercises in the textbook, exercise 5D. So I just wanted to run through a couple of examples to enable you to do that. I've got two examples and then a question for you to practice, and I'll run through the solutions to that as well. And all of this is also on a PowerPoint, which I will upload to Teams, so you should have everything that you need there. But we're moving on to look at intersection of lines today. So the first question reads that we've got a line y equals 3x minus 6, and that meets the x-axis at point A, and we have to find the equation of the line which has a gradient of 4 and which also passes through point A. So I'm just going to sketch this out very briefly first of all. And we have got 3x minus 6, so that's going to go intersect at minus 6 and is going to have a gradient of 3. So that will look something like so. Now to determine the coordinates of point A, which we need to do first of all, we can say that at point A, because it is on the x-axis, y must be equal to 0. And so therefore, when we consider the line y equals 3x minus 6, if y is equal to 0, 0 is equal to 3x minus 6, which means 3x equals 6, which means that x must equal 2. So therefore, the coordinates of point A must be 2, 0. Now we're asked to find the equation of the line, and we are told that the gradient is 4. So using what we had a little look at the end of last term, we can use y minus y1 is equal to the gradient of x minus x1. And then we can just substitute in the coordinate points of A for y1 and x1. So we have got y minus 0 is equal to, the gradient I'm given is 4, and x minus 2. And now here I can just expand, so I would end up with y is equal to 4x minus 8. And that would be the end of that question there. I have found the equation of the line, and I can leave it like so. Okay. Moving on to have a quick look at example 2. As I say, this is all uploaded on a PowerPoint, which might be slightly easier to read for you, but I've got it here as well. We have got the diagram shows two lines which intersect at P, and we can see that the lines are y equals 3x and x plus 2y is equal to 4. And they intersect at point P, and the first thing I'm asked to do is determine the coordinates of point P. So as they intersect, I can say the y values are equal. And so what I'm going to do is substitute y equals 3x into this equation here. And then I've just got an equation in terms of x. So I can say I've got x plus 2 lots of 3x is equal to 4. And that would tidy up to be 7x is equal to 4. So if I divide both sides by 7, I have got that my x coordinate is 4 over 7. To find the y coordinate, I'm just going to substitute this in to y equals 3x. And so therefore I can say y is equal to 3 times 4 over 7, which is equal to 12 over 7, and so point P is equal to 4 over 7, 12 over 7, there. The second part of this question says the line x plus 2y equals 4, which we can see is this line here, intersects the x-axis at point Q. Determine the coordinate of Q and the area of the triangle OPQ. So the first thing that I need to do is determine the coordinate of Q. Now, similarly to what we looked at above, at point Q, y is equal to 0. Now the line is x plus 2y equals 4, so therefore if y is equal to 0, I can simply deduce that x is equal to 4. So therefore the coordinates of Q are 4, 0. Now I'm asked to determine the area of triangle OPQ, so that is this triangle here. Now I know that this has got a base length of 4 and a perpendicular height using the y coordinate that I found in part I of 12 over 7. And so therefore the area of OPQ is equal to 4 times 12 over 7 times by a half because it's a triangle, and that would give me a final answer of 24 over 7, and I can leave it like so. Okay, what I would suggest you do from here, either using the PowerPoint or the question I've written up here, is have a go at the test your understanding question. So I pause this video now and then I'll run through the solution, so come back and check you've got it right before going on to the textbook exercises. So pause here and have a go. Okay, hopefully having done that, if we run through the solutions to that one here, we've got the line L1 passes through the points -1, 3 and 11, 12. Find an equation for L1 in the form ax plus by plus c. So the first thing that I'm going to do is find the gradient. So we can say that the gradient of L1, remember, is equal to y2 minus y1 over x2 minus x1. So if we were to do 12 take away 3 divided by 11 take away -1, we would have 9 over 12, which simplifies to 3 over 4. So we have got that the gradient is equal to 3 over 4. Now again, using what we looked at the end of last term to find the equation, I'm going to substitute in, you can choose either coordinate, but I am going to choose in this case to substitute -1, 3 into y minus y1 is equal to m lots of x minus x1. So here I've got y minus 3 is equal to 3 over 4 x minus -1. So the first thing I'm going to do is multiply throughout by 4 to eliminate the fraction here. So I've got 4y minus 12 is equal to 3 lots of x, and then take away -1 becomes +1. And if I expand the brackets here, I've got 4y minus 12 is equal to 3x plus 3. Now I want to write this equation in the form ax plus by plus c. So I need to have everything on one side of the equal sign. So therefore I am going to leave the 3x as it is here, subtract 4y from both sides and add 12 to both sides to end up with 3x minus 4y plus 15 is equal to 0. And that is the equation of L1. I'm then told that the line L2 has equation 3y plus 4x minus 30, and I'm asked to find the point of intersection for L1 and L2. So I'm just going to write them both out again. So we have got L1 is 3x minus 4y plus 15, and L2 is 3y plus 4x minus 30. Now, much like when you're wanting to solve simultaneous equations, you want the coefficient of either x or y to be the same. So I'm going to make the coefficient of y the same by multiplying this equation by 3 and this equation by 4. So in that case, I end up with 9x minus 16y plus 45 is equal to 0. And in this case, I end up with 12. Sorry, that's 12y, isn't it? 12y plus 16x minus 120 is equal to 0. And now the coefficient of 12y is equal. So, by rearranging this equation here, I can say 12y is equal to 9x plus 45 by just adding 12y to both sides. And I'm now going to substitute this into the equation for L2. So instead of this 12y, I'm going to write 9x plus 45 plus 16x minus 120 is equal to 0. If I collect like terms here, I have got 25x minus 75 is equal to 0. And then we can say 25x is equal to 75, which means that x is equal to 3. Using this value, you can substitute into either L1 or L2, or this value here. It doesn't matter which. I'm going to substitute into 12y equals 9x plus 45. So therefore, I can say 12y is equal to 9 times 3 plus 45, which is 27 plus 45. So 12y is equal to 72, and by dividing both sides by 12, y is equal to 6. And so therefore I'll conclude by saying that the point of intersection occurs at 3, 6, and that there would be your final answer. Using that, if you can now have a go at exercise 5D in the textbook for me, that would be great. If you've got any problems, email me or let me know on Teams, and I will gladly get back to you.